Cathay Pacific.
A crowded flight en route to Hong Kong is suddenly in trouble over the South China Sea.
What the hell was that? Engine 2 stall?
Relying on one engine to get us safely on the ground.
Then the situation gets worse.
We now have 2 engines stalled. This is not fair.
Approach. Mayday, mayday, mayday.
Damn it.
The 200-ton jet with 309 passengers is free-falling towards disaster.
I felt fear.
This cannot be happening.
It looks like this aircraft could end up ditching into the water.
Unless the captain comes up with a better option.
Seatbelt, please. Thank you.
Cathay Pacific Flight 780 is cruising at 38,000 feet over the South China Sea.
This is your captain speaking. We'll be starting our descent into Hong Kong shortly. Local weather is 29 degrees with scattered clouds, so it should be a lovely spring day. Thank you again for flying Cathay Pacific.
Captain Malcolm Waters and his crew are nearing the end of a 4.5-hour flight from Indonesia to Hong Kong. Touchdown is in 30 minutes.
It's a crisp morning, clear skies, light wind. It was a nice day to go flying.
It's only the second time Captain Waters and his first officer, David Hayhoe, have flown together.
So, how long have you lived in Hong Kong?
12 years. Moved there when I was 23.
Waters is one of Cathay Pacific's youngest captains. Hayhoe is an ex-fighter pilot with the Royal Australian Air Force.
So what's it like flying F-18s?
Oh, there's nothing to it. The in-flight service is terrible.
Flight 780 originated in Surabaya, Indonesia. It's covering more than 2,000 miles to reach Hong Kong. The Airbus A330 is powered by 2 Rolls-Royce Trent 700 engines. And every aspect of flight operations is aided by advanced computers.
The engineering and complexity that goes into them and the science that presents the information, they're incredible machines.
Seatbelts, please.
Madeline Avesado is the in-flight service manager responsible for overseeing 10 cabin crew members tending to 309 passengers.
We carried out the service and prepared for landing. It was a normal flight.
165 miles from Hong Kong Airport, the Airbus leaves cruising altitude and begins its descent.
Airspeed's 295 knots. Rate of descent 700 feet per minute. It's looking good.
The aircraft is performing perfectly. And then something goes wrong.
What the hell was that?
Strange.
I describe it as a low thumping noise and airframe vibration. So, David and myself kind of looked at each other like that's unusual.
The flight computer is alerting the pilots to a problem.
Okay, let's see what we got.
Engine 2 stall.
The plane's monitoring system indicates there's an issue with the right engine, engine number 2. Captain Waters tries to understand what happened to the engine, but the monitoring system gives him no explanation.
Now, when we were checking the parameters, they were relatively normal.
Okay, thrust lever number 2. Confirm.
Confirm?
With no explanation for the incident, Captain Waters reduces power on the engine to idle to protect it from damage.
Idle.
The lowest possible power level while still keeping it running. It has an immediate effect. The engine noises disappear.
That's better.
All the symptoms went away.
We've got fuel flow, we've got rotation.
The bigger concern is that the engine at idle isn't providing any thrust. They must now rely on their other engine to get them to Hong Kong.
A single engine approach is not a big deal. We practice it a lot in the simulator. The aircraft are certified to fly on one engine.
Hong Kong, Cathay 780. Pan, 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 pan.
The crew alerts air traffic control of their situation.
Pan, 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 pan.
Sir, we have a pan-pan call.
We declared a pan, which is sort of the first level of urgency.
We're operating engine 2 at idle thrust at the moment, but operation's normal apart from that.
Cathay 780. Roger your pan.
If we could just get priority. Thanks.
You declare a pan in order to let air traffic control know that we need a bit of help to get us on the ground quickly, and it gives them the authority to push people out of our way and help us achieve that goal.
Cathay 780, understood.
The controller grants the request.
We have a pan-pan call from an incoming flight. Please put emergency services on standby.
Airport firefighters rush to take up positions near the runway. Flight 780 is 115 miles from Hong Kong Airport. The plane will be on the ground in 22 minutes.
In preparation for landing, please stow tray tables and return your seats to the upright position. Matt's here.
It's not normal for captains to call during a pre-landing announcement by the in-flight service manager.
Matt, we're having a problem with engine number 2. I need you to keep an eye on it from the cabin.
Roger.
He requested to check the engine number 2 if there's something unusual or if you can smell any smoke. I checked the engine and it was pretty normal, nothing unusual going on.
The pilots prepare to land the Airbus with only one engine.
I'll take the landing.
Understood. You have control.
Captain Waters will fly the plane from this point on.
I have control.
In an emergency situation, the most senior crew member assumes the flying role. Now I have to actually do what I've been trained to do. So it's not a normal day anymore, and you have to be on your game.
Everything is set for landing.
Engine 1 stall.
Engine 1 stall confirmed.
It's the last thing they want to hear. The monitoring system confirms their worst fears. They have just lost their other engine, the one they were relying on to get the plane to Hong Kong.
We now have 2 engines stalled. This is not fair.
The crew of Cathay Pacific Flight 780 is facing the loss of their one remaining engine.
We were relying on this one engine to get us safely on the ground, and now it had exactly the same symptoms and noises and sounds as the other engine.
If they can't get it back up and running, the plane is headed for an unimaginable disaster.
Engine 1 to idle.
The monitoring system tells the crew to put the malfunctioning engine number 1 into idle. Just like engine number 2, it's still running, but producing no thrust. The plane is now gliding.
Damn it. Our descent rate is not looking good.
Without thrust, they can't make it to Hong Kong or any other airport.
Still 60 miles out. Too far.
We were still about 60 miles out to sea at that time. With the aircraft descending at, 1,300 feet per minute, we've only got 5-6 minutes before we're at sea level. I felt fear. And you have all those human responses to fear. The hair standing up on the back of your neck, the tightening of your stomach, the dryness in your mouth.
It was a sense of disbelief that we might end up in the water. This can't be happening.
Though the cabin is now quieter than normal, passengers have no idea about the danger they face.
Everything was calm. Everything was like normal to them.
There's an initial moment of that shock and how are we going to start overcoming this problem?
Without the power to make it to Hong Kong, the pilots now face an emergency landing or ditching in the South China Sea.
What do you think?
I'll start the ditching checklist.
Good idea.
I suggested carrying out a checklist procedure to prepare the aircraft for the correct configuration for the ditching itself.
Sitting back allowed me to start thinking rationally.
Captain Waters tries the throttles one more time. He increases power on engine 2. Then 1.
Nothing happens. The engines just are not responding at all. They're just remaining at idle.
Damn it!
I'm calling a mayday.
Do it.
Approach. Mayday, mayday, mayday. Cathay 780 had engine 1 stall and engine 2 stall.
The first officer puts out a more urgent distress call.
Currently, we require a lower descent. We're extending our glide and trying for relights.
Cathay 780, descend to 3,000 feet.
Putting the mayday call out over the radio, you really feel that something serious is going on. You can tell in the voice that comes back to you that it gets everyone's attention because it's not a word that you hear all the time.
Restarting number 2. Ram air turbine on.
In between the ditching checklist itself,
Engine 2, select ignition.
my approach was, let's try and restart the engines because we're going to be in no worse a situation than we are now.
No response. Still at idle.
Now the pilots contemplate their options for ditching. The previous year, a US Airways Airbus landed on the Hudson River in New York without a single casualty. Captain Chesley Sully Sullenberger became an instant hero.
The Sully incident had been the first successful ditching, really, of an airliner, and to show that it could be done.
But as they drop towards the South China Sea, the crew of Flight 780 are facing far more treacherous conditions.
Big swells. The South China Sea is not the Hudson River.
The sea looked very rough. It was a lot of white caps. The swells would be 1 to 2 meters. I felt that our engines had acted as 2 big scoops, and we pitched the aircraft down quite violently, and that would probably result in us, cartwheeling and breaking apart.
This cannot be happening.
Both pilots know they're running out of time. Cathay Pacific Flight 780 now has 2 unresponsive engines. Passengers on board are unaware how close they are to disaster, just minutes from ditching in the South China Sea. Captain Waters takes manual control of the aircraft to ensure the safest water landing possible.
Turning off the flight director. Flying by hand now.
Roger that.
So I start maneuvering the aircraft to keep it clear of clouds so that I can see the ocean and start to make an idea of where I'm going to put the aircraft.
That's when Captain Waters gets an idea.
Okay. Try slow movements. Go slowly. Just ease in fuel. Easy does it.
I could see Malcolm manipulating the thrust lever for engine 1.
I was just pinching the side of the thrust lever just to move it a millimetre. Each time I pinched it would just go up a millimetre.
Slowly. Slowly.
Incredibly, it seems to be having an effect.
Rotation increasing in engine 1.
It's working.
The rotation of the fan was increasing from 28% to 29 to 30 to 32 as I moved this very, very slowly and gently up.
Let's see how far we can get.
He wonders if he can get the engine to full power.
I eased the thrust lever up a little bit more.
Too much.
We had surges and popping and wumping noise, and I immediately set the thrust lever back to what thrust we had.
Waters figures out that the engine won't go any higher than 74% power.
74%. That'll have to do.
We got a thrust setting that resulted in us being able to fly level. We weren't descending anymore, and that was like a huge relief.
You see that? Altitude is holding.
Fantastic. Okay, approach preparation. Cockpit prepared. Loose items secured.
One engine is all they need to attempt a landing at Hong Kong Airport.
Visual 07 left.
I knew we were going to make Hong Kong. And it's very clear we have enough energy now that we're going to be able to get to land.
Track 073.
Checked.
We can do our landing so infinitely better than ditching.
But Captain Waters still needs to safely land a plane with engines he can't rely on. He's not sure how much longer Engine 1 will keep providing thrust.
We did have an engine that was now functioning, but I didn't trust it. At any point, I believed that we possibly could just roll back to idle thrust again.
The safest plan is to get the plane 5,500 feet above ground and then reduce power on the engine to start losing speed and altitude for landing. They could be on the ground in less than 5 minutes.
We wanted to stay as nice and as high as we could in a position that we could manage a glide.
Let's do this.
Engine 1 has brought the plane as far as it needs to. Captain Waters pulls it back to idle to lose speed.
I closed the thrust lever and I began my approach essentially for the arrival.
230 knots. We're at 3 miles.
Checked.
If all goes well, they should be on the runway in less than 4 minutes. But they'll only have one chance to get the plane on the ground. If something goes wrong, they don't have enough thrust for a successful go-around.
Ladies and gentlemen, this is the captain speaking. As you may be aware, we have a small problem with our engines. Remain seated with your seatbelts fastened and follow the directions from your cabin crew. Cabin crew to landing stations. Okay, flaps 1. Thanks.
Okay, flaps 1.
Gear down.
Gear down.
The crew deploy flaps and landing gear to prepare for landing. There's only 5 miles to go.
Cathay 780. Do you have the airfield in sight?
Cathay 780.
Affirm.
Hong Kong Airport has 2 parallel runways. It's built on an island west of the city.
Cathay 780. We have both runways available for your approach.
The crew is cleared to land on either runway. The Airbus turns onto its final approach to Hong Kong Airport. Captain Waters is confident he can get the plane on the ground safely.
Auto brake.
Low.
Final items. Okay.
They're a minute from touchdown.
It's overspeed.
It's an overspeed warning, a signal the aircraft is flying too fast.
The speed was not reducing to anything close to the speeds that were indicated that we would be once we got into the landing configuration.
Captain Waters can't figure it out. They should be slowing down. He rechecks the controls.
It just looked completely wrong, and I was very uneasy that things were, once again, to get out of my control, and that there was something that I was missing.
Then he sees it.
I looked up at the gauges and, my blood ran cold.
Engine number 1, which he throttled back minutes earlier, is inexplicably still running at 74% power. High thrust, too high to land safely.
I had that whole feeling again of fear, anger. It was a scary moment.
After dealing with double engine trouble, the crew of Flight 780 is now facing a new crisis 1 mile from the runway.
Speed checked. 240. 800 feet.
The engine they put in idle for a safe, smooth landing is still running at high speed. The outcome could be catastrophic.
500.
I could not believe that we'd gone from a situation where we were looking at ditching, and now I had an engine stuck at high thrust.
With no option for a go-around, they're going to have to risk landing the plane at high speed and hope they can stop it before overshooting the runway and ending up in the water.
Got 12,500 feet of runway, Mal.
Checked.
We couldn't determine how much landing distance was required. We were off the chart, for the speed and for the weight that we had.
400 feet.
The longer we prolong this, the more unknown things are happening.
It was our one chance to get this on the ground, and we had to make the best go at it.
Too low. Terrain. Too low. Terrain.
Their speed is 100 knots faster than normal, so high the flight computer doesn't recognize that the pilots are trying to land.
It's warning the pilot, like you are putting the aircraft in a dangerous spot, and those warnings are loud for a reason. And I just had to put it all to the side, focus on what I was trying to achieve.
Disregard that.
Captain Waters pushes the nose down, forcing the Airbus onto the runway.
Terrain. Pull up. Terrain.
The aircraft did not want to land, and I remember thinking, wow, this is it, because it was very violent.
I thought we're going to crushed and into bits and pieces.
Brace!
I managed to keep that wing up high enough that I just grazed the surface of the runway, and I got it back under control.
We're down.
Finally, the aircraft is firmly on the ground.
Full reverse.
The crew deploys reverse thrust on the engines to slow the Airbus down while applying full braking power.
Immediately, I just step on the brakes, hold them, toe brakes to the floor.
No number 2 reverse. No decel.
But with only one partially functioning engine, they only have one thrust reverser. They could still overshoot the runway.
I still didn't think we would stop by the end.
The Airbus is getting close to the end of the runway.
I could judge the deceleration rate was such that, I started to get a glimmer of like, man, I think we really, we could do this.
Finally, the aircraft comes to a halt just a short distance from the water's edge. They've used up more than 8,800 feet of runway.
I can't believe it.
We made it. Nice one.
Once the aircraft did stop, there's a look of what the hell just happened.
It was just this humongous relief. You're so happy that, we were going to go home and see our families.
Against all odds, Flight 780 has landed safely, but it isn't out of danger yet.
Check the wheel temps. We may have to order an evacuation. Get the checklist.
The crew worries that the extreme braking may have caused their wheels to overheat.
Both approaching 1,000 degrees.
Their hunch is correct.
Oh my goodness, we've got to be on fire.
We need to get everybody off the plane. This is the captain. Evacuate! Evacuate! Evacuate!
Come this way and leave everything behind.
The passengers and crew evacuate safely with only a few minor injuries.
Once I was standing on the ground, I turned around and looked at the aeroplane, and it was like a scene from a Hollywood movie. The steam and smoke coming off the fire services were dousing the wheels, and paramedics are turning up. People are being helped away from the bottom of slides.
Within hours, Hong Kong's Civil Aviation Department launches an investigation. Anne Evans is a flight test engineer who works for the British Air Accidents Investigation Branch. She's been invited to take part in the investigation, in part because the Airbus's Trent 700 engines were made by British company Rolls-Royce.
This Trent 700 is a very common engine fitted to a lot of aeroplanes all over the world. So if there's an engineering problem with a particular design, then we want to find that quickly.
Here's what we know. The engines on Flight 780 failed to respond to throttle commands.
Investigators meet to discuss the few clues they have.
It's odd that both engines stalled.
They're struck by the fact that the same malfunction affected both engines, one after the other.
It's very rare to have two systems fail at the same time, given the level of redundancy and reliability that's built into the engines.
It suggests the cause may not be the engines themselves.
Critical systems like that don't fail simultaneously.
Could something far more mysterious lie at the heart of the problem? In Hong Kong, investigators work to unravel the mystery of Cathay Pacific Flight 780's 2 malfunctioning engines. They retrieve the black box flight data recorder from the rear of the aircraft. It contains information about the plane's functions throughout the flight.
The data on board the aircraft is key in this type of investigation.
Investigators upload the data from the recorder.
We need to see throttle position and fuel flow.
The device records 359 data parameters. They focus in on the A330's engine functions.
Stop. What's going on here?
Right away, they notice something unusual.
Thrust levers are moving, but fuel flow's flatlining.
Right after the pilots tried to restore power to the engines by pushing the throttle up, the fuel flow remained the same.
They gave some thrust commands, but no corresponding response from either engines at the time.
Damn it!
So we really needed to understand what caused that.
Investigators wonder if a fuel flow problem caused Flight 780's engine trouble.
Thank you.
The flight data recorder helps them spot the problem, but to try to pinpoint the cause, they turn to another source of onboard data. It's called the post-flight report.
Engine 2 control system fault. It says that the VSV was jammed.
It contains in-depth data about the error messages that appeared on the monitoring system throughout the flight.
Okay.
It's a piece of information for troubleshooting to tell the maintainers that the aircraft's had a problem and what they need to do to fix it.
Something was retarding the valve.
Anne Evans discovers that early in the flight, the computers detected a problem in a key part of the fuel system called the main metering valve.
So the warnings that were coming up were warnings to do with the main metering valve supplying fuel to the engine.
The main metering valve is made up of a piston that slides within a cylinder. When pilots move the thrust levers, it increases or decreases the flow of fuel to the A330's turbofan engines.
That valve wasn't moving, wasn't able to respond to the commands.
To better understand why the metering valve malfunctioned, investigators send it to Rolls-Royce for analysis.
We have the best expertise about to strip those components here in the UK, and we'd cut the outer sleeve of the metering valve in half to see what was inside the metering valve.
After cutting open the valve to study it,
That's not normal, is it?
they find something they've never seen before. A strange white substance coating the walls of the valve.
What we saw seemed like very, very fine powder, even finer than caster sugar, very, very small particles.
Technicians examined the white powder under an electron microscope. They discover it's made up of tiny spheres stuck to the metal walls of the valve. Investigators dig deeper to see if the powder can be found in other parts of the fuel system.
We immediately started finding small particles even within the fuel tank itself. So the fuel system and the engine had some sort of contaminant that we didn't really understand what it was.
Could the mysterious particles in the fuel system explain why the pilots had such difficulty controlling engine power?
The metering valve was kind of deluged with this material which would silted the metering valve up and caused it to become stuck in its current position.
Investigators need to learn all they can about the strange substance.
Having identified this particulate within the various areas of the fuel system and the engine, our first thought, well, what is it?
X-ray spectroscopy reveals the chemical makeup of the material. The analysis shows that the powder is a type of superabsorbent polymer, or SAP. When it comes into contact with water, it creates a gel-like substance.
These are organic compounds designed to absorb water. That gave us a clue as to where they'd come from.
Investigators know that the powder is used in refueling trucks to prevent water from getting into aircraft fuel tanks. The refueling trucks pump fuel from underground tanks and pipes through a filter on the truck and into the aircraft. If the fuel is contaminated with water, the powder in the filter absorbs it by forming a gel inside the filter.
So the superabsorbent powder is there really to just absorb the water and make sure that we're protecting the aircraft from the presence of water in the tanks.
But the waterlogged gel is supposed to stay in the filter. It should never end up in the fuel.
It is so commonly used within the industry for this purpose of filtering out water. What we didn't understand was how did it get on board the aircraft?
Investigators suspect that filters in a fuel truck at Surabaya Airport may have been involved in the dual-engine failure of Flight 780. To find out, they recover the filters and take them to a lab for testing.
This one looks somehow collapsed.
They discover that one of the filters on the truck used to refuel Flight 780 is damaged.
The condition of the filters was very unusual.
We were all very surprised to see the crushed filter because that don't normally happens, and it was probably an indication of something abnormal having occurred during the refueling of the aircraft.
Investigators wonder, did the damaged filter somehow release powder into the fuel? They separate the layers of filter material.
We undertook a very laborious process of dissecting the filters, all the different layers designed to not only take away water, but also catch any particulate as well.
They then examine a sample under a microscope. They make a puzzling find. Within the filter fibers, the powder made up of spheres contains an unusual feature.
It looks like sodium crystals?
The spheres are encrusted with salt.
When we found out that there was salt involved, that was really mysterious to us because salt is not normally found in the fuel.
Had salt water got into the fuel system?
This one's straight from the manufacturer.
Finding answers requires more tests, this time with a brand new filter.
What we wanted to do was test these filter monitors to see could we produce these spheres and what conditions did you need to have for these spheres to be created.
They expose the filters to salt water under pressure, the same pressure used inside the fuel truck.
We tried to mimic those conditions, the fueling process that would have occurred in the dispenser.
They soon have an answer.
Well, would you look at that?
It's a major discovery. When fuel and salt water pass through the filter, it collapses, just like the one from the airport fuel truck in Surabaya.
We were able, on the fuel rig, to be able to collapse a filter. So we knew we'd got pretty close to reproducing the conditions that we'd seen on that day.
Even more significantly, they find the test filter releases spheres identical to those found in Flight 780's fuel system.
What was important was that we demonstrated we could generate spheres.
Investigators now believe salt water was responsible for the collapse of fuel filters, leading to powder contamination in the fuel system of Flight 780. But one critical question remains.
So, how did salt water get into the fuel system?
Investigators learned that prior to departure at Surabaya Airport, Flight 780 was loaded with 54,000 pounds of fuel.
It was very difficult for the investigation team to determine exactly how salt water could have got into the fuel system.
When they dig through the records of Surabaya Airport's fuel hydrant system, they can see that the system is located very near the sea.
March 2010. This was taken just days before the incident. I think we may have our answer.
They discover that the underground hydrant system that stores and supplies fuel to the pump truck was recently upgraded. During construction, the fuel pipes had been opened up and possibly exposed to groundwater.
There had been construction work on the hydrants, and the investigation team highly suspected that would have been an opportunity for salt water to come into the hydrant system.
If then the pipes are not flushed sufficiently, then that salt water could still be present when you start refueling aircraft.
Investigators now believe they know what happened to Cathay Pacific Flight 780. The underground fuel supply, contaminated with salt water, broke down a filter, releasing a powder into the fuel. The powder jammed the metering valves, preventing enough fuel from reaching the engines.
Engine 1 stall.
We had fuel contamination, and that contamination throughout the fuel system led to the seizure of both main metering valves, such that the pilot no longer had control over the power of the engines.
Investigators believe Captain Waters was able to restore some thrust in engine number 1 only because its fuel metering valve wasn't yet completely jammed. Some fuel was still getting through.
Slowly, come on.
Rotation increasing in engine 1.
It's working.
Once the spheres jammed the valve, it was stuck open.
Brakes!
Expert piloting brought Flight 780 safely to a stop.
Can't believe it.
Nice one.
I think the crew did a great job. It's not an emergency that's trained for.
We can be very thankful to the crew. They behaved in a very professional manner, and they have our admiration.
Since the accident, there have been efforts to improve the regulation of aviation fuel handling and storage. The company that manufactures the filters has redesigned them to prevent collapse and powder contamination. For their outstanding courage and skill, Malcolm Waters and David Hayhoe were given the highest honor in civil aviation, the Polaris Award.
It was very special to be given the award. It was an incredible honor.
It was the Federation of Air Pilots that awarded that award. So when, your fellow pilots, you say, job well done, we really think that, you pulled it off. So, yeah, very humbled and honored.